Hi, and welcome back. We're looking at ShaperBox 3 today from Cableguys, and I'll start by informing you that this video is sponsored by Cableguys, so don't expect an impartial review. Rather, I'm going to run you through the workflow and the features with a particular emphasis on the new ones. But by the end of the video, you should hopefully have a pretty good idea of what this plugin is capable of and whether or not it's something you can find use for. A word of warning, however, halfway through this video, you might be starting to conclude that it's only useful for EDM producers looking for groovy or glitchy ear candy effects. If that's not you, you may want to stick around till the end, as I'm going to show you lots of ways this can be useful, regardless of the genre you're working in. Because this is a very deep and powerful plugin. It's not just a multi-effects plugin in which you can chain effects in different orders. Each effect can be multiband if needed, with its own individual crossover settings. But perhaps the biggest selling point is the graphical modulation available for all the most important parameters. These can be set up as tempo-synced LFOs, or more like looped sections of parameter automation, or complex envelopes triggered by transients in the audio signal, or by transients in the sidechain audio signal. This is how the interface loads up initially, just a blank canvas. You could start by loading a preset from the browser, of course. I'm going to make a confession. I hate browsing presets. It's a large part of the reason why I learned to program synths myself. I find that by the time I've previewed a dozen totally wrong settings, I've started to lose sight of what I was looking for in the first place. But I see that more as a personal failing than anything else. I miss out when I ignore the often excellent work done by the preset designers. So I do really appreciate a good preset browser like this one, which allows you to narrow down your search and minimize the number of totally inappropriate settings you have to wade through. The more complex the plugin, and the more generous the number of presets provided, the more important this becomes. ShaperBox allows you to sync your preset library and download new presets, obviously assuming your DAW has an internet connection, making it even more useful to be able to sort them and keep track of favorites. I'm going to ignore the presets for the rest of this video, however, and focus on dialing in settings directly. And let's start with one of the new ones, the liquid, flanger and phaser. And initially we start with a static flanger, which is really just a very short delay with optional feedback. The horizontal line in the modulation panel represents the resonant frequency of the flanger, so actually the delay time in reality. So we can create a conventional flanger effect by choosing a sine or triangle preset shape, then setting an appropriate modulation rate. Use the arrows to step through simple tempo-synced divisions, or click to show a menu with triplet and dotted options, or a fixed rate in hertz, which might be the best choice for a traditional flanger effect. Other, more complex preset shapes are available. Something like this can be nice for a less obviously cyclic modulation effect. But importantly, the shapes are very quick and easy to edit or dial in from scratch. You can drag nodes around freely and lasso multiple nodes to move them together. You can double-click to add a new sharp-edged node, or drag a line to add a new curvy node. You can click a curvy node to make it sharp-edged, or click a sharp-edged node to make it curvy, or shift-click for a subtler, smaller curve, or double-click to delete. You can expand the wave display for detailed editing if you want, but note that the interface is resizable, so you can make it as big as you need it. If this isn't easier, faster, and more fun than automating parameters in your DAW, then I want to know which DAW you're using. Okay, now let's try the volume shaper. That may not sound so exciting at first, but actually this one is incredibly useful. For trancegate type settings for a start, I'm going to enable snapping to the grid, then pick the straight line tool. If I click and hold, I can then drag up or down, or left or right, to set a second point, and ShaperBox will remember that for the next click, so I can quickly and easily create hard-edged steps. Alternatively, the arc tool can define 2 points with a curve in between. And you can drag vertically to set the height or depth of the curve. Or the S-curve tool can predictably create S-shapes. Note that these shapes are all created using multiple regular nodes, so you can tweak them further using the default arrow tool if required. Down below, we can double up the pattern with the 2x button, and then perhaps add some variation for the second half. Or we can incrementally shift the wave left or right. The wave menu provides various useful options, including the ability to set a triplet timing for the grid. If you're feeling lucky, you can even randomize the position of all the nodes. Or you can hold Shift and only randomize the vertical position of each node. If your luck isn't in, however, feel free to use the undo feature to get back to safer ground. Trancegates are far from the only thing the volume shaper is useful for, however. Rhythmic pumping is a big part of many electronic styles, and ShaperBox allows you to control this directly and precisely define the resulting groove. This is much quicker and easier than messing about with compressors and sidechain signals, which is the more traditional way to achieve this effect. But you can trigger the ducking from a sidechain audio signal when that's necessary, perhaps so it can follow a complex kick drum pattern. The wave pattern now resets in response to transients in the sidechain signal, with remarkably consistent and clean triggering, free of unwanted flams. You can tweak the triggering if needed by opening up the settings menu. And we now see the incoming transients in relation to a threshold, which we can drag up or down accordingly. 3 different triggering modes are available for different types of audio signal. And there's a detail slider to adjust the transient sensitivity. You might need to adjust these settings if you're triggering from something complex, like a mixed loop. But with a simple kick drum sidechain signal, the defaults are all fine. Let's hide the triggering settings again. And remember that we have multiband options here. If I drag the lower crossover to the right, we now have 2 bands of ducking available. I could set this up so that only the low frequencies of the bass get ducked in response to the kick. Or I could set up dramatic pumping for the low frequencies, but much faster and more transparent ducking for the mid and high frequencies. Notice that, despite the infinitely sharp, snapped-to-grid initial attack I've dialed in, we're not hearing any obnoxious clicks. Presumably this is due to the look-ahead pre-smoothing that I see in the new features list. This does suggest that some settings are going to introduce latency, and ShaperBox might occasionally warn you at the top that you need to restart playback because the latency has changed. But whatever I do, the latency remains low enough to play synths or guitars through it in real time. And indeed, low enough that I only really know it's changed when the interface tells me so. So what else do we have? There's a filter shaper with various filter options, including saturated, warm filter types. Let's add a healthy dose of resonance and modulate the cutoff in an interesting way. I actually want the cutoff to stay within a fairly narrow range in the mid-range, however, no problem. I'll right-click, select all points, and then scale the box accordingly. Now I'll follow it with a crush shaper, with some of my favourite sample rate reduction, so that the aliased partials start to create cool vowel sounds. And let's have some modulation for that as well. If I pop back to the filter, I can offset the left and right channels slightly to create a pseudo-stereo effect. But I want the lowest frequencies to remain safely mono, so I'll also add a width shaper, drag the low crossover up to 100 Hz or so, and maybe make it steeper. And then set the low band fully mono. Okay, we need to talk about the time shaper, which is exactly as profound and powerful as it sounds. It starts with a horizontal line at the top of the graph. This represents normal real-time playback. If I drag this line halfway down the graph, the part is now delayed by half a bar, but still plays at normal speed. If I create a downward slope, however, that now plays at half speed, but the horizontal section still plays at normal speed. Conversely, an upward gradient will speed up the playback. And the display above shows where your playhead is within the buffer of audio that you're manipulating. Notice this diagonal line with a shaded region below it. This line represents the audio waveform standing still, which results in silence. Actually, it's the gradient that matters. Any line running parallel to this will stop the playback and you won't hear anything. But if you go further and create a steeper gradient, that region now plays backwards instead. Lots of cool possibilities present themselves via the suggested waves below. The stutter waves can chop up loops into new patterns. The scratch and tape waves do various types of slowdown or speed up effects. While the patterns might combine both. Of course, we can change the loop length. And the same pattern presets now give totally different results. By default, the maximum delay available at the bottom of the graph, or the size of the audio buffer that we're scrubbing through, depending how you want to think about it, is linked to the loop length. So we now have 2 bars of delay available. You can change that, however, and set the buffer size manually. And this will change the gradient at which playback stops, so the shaded area will change accordingly. If you wish, you can store up to 9 different waves into the custom slots below. Then use incoming MIDI notes to switch between the waves. The uses for this are many and varied. You can warp melodies or chord patterns into entirely different melodies or chord patterns. Chop up and rearrange drum loops on the fly. Or trigger cool spot effects over the whole mix. Okay, let's talk about noise. Here's a noise shaper. And by default, with no input signal, we just get silence. That's because the dynamics are enabled by default, so the added noise is modulated by an envelope follower on the input signal. This means we can easily add extra noise to a snare drum, for example, which can often be useful, especially when you have filtering options as well. You can mute the input signal to leave just the noise, which might be useful if you want to run this as a send instead of insert it on the channel. For even more control, you can disable the envelope follower and turn on audio triggering instead, to trigger precisely shaped bursts of noise for each drum hit. But static noise can also be useful, with neither envelope following nor audio triggering. Indeed, with a noise generator as the first effect in the chain, ShaperBox essentially turns into a synthesizer, when we actually have a load of different noise flavors to choose from. I'm particularly fond of the watery types myself. With some added filtering, or some liquid modulation, maybe multiband, auto-panning and width modulation, you can create a complex, ever-evolving ambient drone. On the subject of more synth-style options, I'm going to demonstrate this one with a simple sine wave to make the effects easy to hear. Here's a volume shaper with a sawtooth preset for the modulation. I'm going to click the timing menu and choose MIDI notes. And I'm now doing audio rate AM with the modulating frequency determined by incoming MIDI notes. And if you like that, you're going to love audio rate modulation of other parameters, like, say, filter cutoff. One of my favorite things to do with sine waves, however, will require a drive shaper. This can do analog style soft and hard clipping, which I'll look at in more detail later on. For now, I want to focus on the wave shaper settings at the bottom. These add harmonics in complex patterns, more reminiscent of FM synthesis than analog distortion, and the different types each sound quite different. You can also bias the wave shaper to make it asymmetric, which again sounds quite different. But this is still just a simple sine wave audio input. The complexity of the results from this type of distortion increases exponentially as the complexity of the input increases. I'm going to add one more sine wave, playing a harmony line that hits various intervals, some more consonant and some more dissonant. And listen to what happens when I enable the wave shaping again. Of course, the input signal still has no dynamics whatsoever. The input level has a dramatic effect on the amount and type of harmonics that are added. So an 808 style boom might end up sounding more like an FM bass patch. But absent any dynamics, you can achieve much the same effect by modulating the drive, which is just compensated input gain anyway. Right, I'm going to dedicate the next portion of the video to generally useful techniques that can help you out regardless of the genre you're working on. Here's a real multi-track drum kit recording. And here's just the inside kick mic. I'm going to set this volume shaper to trigger from incoming audio transients, then design the perfect noise gate with precisely the right curve when closing. We can view the triggering settings if required and adjust the triggering threshold or transient sensitivity, but I haven't needed to in this case. The triggering is consistent and clean even with these default settings. Okay, so let's try the same thing for the outside kick mic. There's more spill on this one, and the snares are also triggering the gate. I could try to fix that by filtering the sidechain, but in this case it makes more sense to switch to the external sidechain, to which I've routed the other kick mic, because we already know that triggers perfectly without any tweaking. Okay, let's bus those both together and process them with a compressor. A couple of things to note about the ShaperBox compressor. First of all, the ratio increases when you drag the slider down. That's weird and counterintuitive for about half a second, until you realise that dragging the fader down results in more downward gain reduction, and it all makes sense again. At least that's how it went for me. Also note that auto-release is turned on by default. This appears to be a type of auto-release that adds extra program dependency, while still allowing you to adjust the overall release speed. But be aware that turning this off allows for much faster and more aggressive sounding release behavior, which might work better for some sources. Also be aware that auto gain defaults to on. I have strong opinions on compressor auto gain, which I don't want to go into in this video as it's too long already. Let's just say that I usually prefer to set the makeup gain manually. But that's especially true in this case because what we actually have here is multiband compression, which means the gains aren't just volume controls, they're actually a rather powerful 3-band EQ. Listen to the difference when I bypass this. Who needs a Pultec, right? In fact, the EQ curve I've created using the individual band gains is way more important than the actual compression in this case. Here's the rack tom with a noise gate setting. Except this is actually a 3-band gate. The lowest frequencies stay open longer, with a fat, round-sounding hold period before closing down, while the mid-range frequencies have a simpler exponential decay, and the high frequencies clamp down super fast after each transient to eliminate cymbal spill, which can often be a big problem on tom mics. And as a bonus, I can also use the gain trims for each band to EQ the drum, pull out that boxy mid-range, and hype the bottom and especially the top. And now consider that you can have multiple multi-band processes in a single ShaperBox. For example, a drive shaper, plus a volume shaper, plus a compressor, each with their own crossover and gain settings, allowing for some rather complex and powerful EQ settings. Just to make the point, I've mixed the drums using nothing but ShaperBox. Here's how it sounds when I bypass all instances. Now, I'm not suggesting you delete all your EQ plugins and just use ShaperBox instead. Just that if you've already loaded it for a noise gate, you might find it can tick a lot of other boxes as well. We do need to talk about crossovers, however. These can be set to 6 dB, 12 dB, or 24 dB slopes. In EQ terms, 6 dB will give very gentle, natural-sounding curves. 12 dB will be like a normal shelf response. And 24 dB will provide steeper and slightly more surgical shelves. Do note that these are minimum phase crossovers, however. With a 12 or 24 dB slope, you'll get 180 degrees of phase shift at the crossover frequency. This does have some implications. If you run these settings in parallel, you'll get cancellation at the frequencies that are rotated 180 degrees, potentially creating hard notch filters if the gains are at unity, which might not be what you want. There are a number of ways you can fix this. First of all, the 6 dB setting won't cause any such issues. Any phase shift in this case is super gentle, much like a gentle shelf EQ running in parallel, and we all know that's nothing to be scared of, right? Alternatively, run the plugin as an insert, but use the mix controls to create parallel processing instead. Why does that make a difference, you may ask? Well, the mix controls are actually per band. If I turn this one down, then switch bands, this mix parameter is separate and independent. This has two implications. First, and perhaps obviously, we can set different dry-wet mix levels for each band, which can be very useful. But also, it means the dry-wet mix happens individually for each band and the crossover is not affected. If I set all 3 bands all dry, this hasn't changed the phase shift from the crossover at all. Here's the clever part. If I set all 3 bands back to fully wet, and use the master dry-wet mix instead, same result. Let me demonstrate that difference in Reaper with a pink noise signal. Here's two 12 dB crossovers. And notice what happens when I set Reaper's own dry-wet mix knob to 50%. There are those notch filters I warned you about. But if I use the master mix in ShaperBox instead, no notch filters. The final fix I'm going to show you for the phase shift is, don't worry about it. That needs clarifying though. I don't mean in a parallel send-return configuration, as that might well cause you problems. But in other situations where people might worry about phase shift, such as a multi-mic'd drum kit, it's often not a problem, or you can even turn it to your advantage. When we say that a drum sound is in phase across multiple mics, we're usually just referring to the fundamental frequency of the drum. It's virtually impossible to get two different mics in different places perfectly phase matched at all frequencies. So we get the fundamental in phase, then just EQ the rest accordingly. So if you tune the crossovers such that the fundamental of the drum is not affected, you're probably not going to do any real damage. As the signals from each mic aren't perfectly correlated to start with, even 180 degrees of phase shift will never cause a hard notch. Much more likely to be a gentle cut instead, which might be useful. Drums nearly always need some cut in the boxy frequencies, around 4, 5, 600 Hz. So try putting a 12 dB crossover in there, move it around till it sounds good. Trust your ears and don't fear the phase shift. Now some of you might be remembering me saying that linear phase crossovers are superior as they avoid all these issues. That's true, but they introduce other issues instead, which would be problematic in this case, namely extra CPU load and latency. It's important to remember that you can run many of these crossovers in series inside a single ShaperBox. The CPU load would potentially be huge with all possible crossovers active. But perhaps more importantly, the latency would be a nightmare. Even just one set of linear phase crossovers would be unplayable in real time, let alone a chain of 6 of them. And the fact that I can still play a guitar through the most complex of settings in real time is really great. So I'm going to declare minimum phase the correct choice in this case, and urge you once again not to fear the phase shift. Speaking of guitar, here's a drive shaper with a guitar part running through it. The hard clipping style is kind of reminiscent of a fuzz pedal effect. But notice this dynamic option we have here. When I turn this on, the distortion starts to react to my playing dynamics. Playing harder results in less headroom and more distortion, while playing more gently or rolling down the guitar volume cleans up the sound like so. And now with the volume back up again. That's a holy grail of guitar sounds right there. However, I find this feature even more useful when doing the opposite. Let's go back to the drums, when I'll start with the dynamics turned off and just push the drums into the soft clipping. The distortion becomes quite obvious quite quickly. Now let's enable the dynamics, but in the opposite direction. So as the signal level increases, the headroom does too, and the distortion kind of runs away from the signal. And notice how different the results sound. I can push the signal much harder into this than I could with the static version. You can think about this in a few different ways. We're emulating the complex hysteresis of some analog types of distortion. We're keeping the signal in the sweet spot for more of the time. We're adding more harmonics to lower level elements without destroying higher level peaks. All these statements are true. Also consider that while the envelope follower seems to attack pretty quickly, it can't be instant, suggesting that the leading edge of loud transients will be saturated harder than the rest of the signal, rounding them out and making them richer and fatter sounding. What I'm trying to say is, this can sound really good. And especially when you consider the multiband capability as well. It makes the Drive Shaper a very powerful and flexible tool for distortion and saturation effects. Multiband distortion can be very useful as it reduces intermodulation between bands, making the distortion seem much less chaotic and gnarly and more focused and controlled. It can be extremely useful for drums, which tend to have a very wide bandwidth to start with. Here's a single band setting. And now the multiband version. But it can also be useful in other contexts. I think guitarists should be more aware of the potential to create distortion effects that are less likely to disintegrate into horrible noise when you play jazzier chord voicings. Okay, one final point about crossovers before I leave you. I've warned a few times about the effects of monoing the low frequencies with a minimum phase high-pass filter for the side channel, like this setting in Pro Q3. When you shift the phase for only the side channel, you change the phase relationship between mid and side channels, which will change the stereo image. That's not always a bad thing. Sometimes the results sound better, so I'm definitely not saying you shouldn't do this. Just that you should pay attention to the way it affects your stereo image, and don't just slap it on routinely without listening to the results. You might expect this to also apply to the width shaper if you use it to set the lowest band mono, as the crossover is minimum phase. But it doesn't. In this case, the crossover affects both the mid and side channels equally. There might be more phase shift than you get with a side channel high-pass filter, depending how steep the filter, of course. But that phase shift is the same for both channels, so it won't change the stereo image, and in most cases will remain totally inaudible. And a final little postscript. With a 3-band crossover setup, we can also play with the relative width of the mid and high frequencies. Many people assume that, as we want the low frequencies mono, and we can't hear stereo differences down there anyway, the opposite will apply to the high frequencies. We'll be super sensitive to high frequency width and want the highs as wide as possible. I would slap a big health warning on that. Excessive stereo width for the high frequencies is a common mistake, which can cause mono compatibility problems, specifically a dullness and lack of sparkle in mono. In that case, you can boost the highs while listening in mono to restore that sparkle, and dial back the high frequency width in stereo to stop it getting too bright. The 6 dB crossover slopes are perfect for this, being nice and smooth and totally free of any potential phase issues. And don't worry, it won't end up too narrow. All the magic is in the mid-range. If that region is nice and wide, no one will care if your high frequencies are narrow or nearly mono. They probably won't even notice. And conversely, if you have a mix that needs widening, consider doing that to just the mid-frequencies, or even just the lower mid-range. Here's a side-channel EQ curve in Pro Q3. This isn't meant as a suggested setting, really. It's more to illustrate where I personally consider stereo width to be important. Below about 100 Hz, I can't hear it, and I don't want any width at all, really. But above that, it gets really important really quickly. I can definitely hear width in the lower mid-range, and I really like it too. It can give a huge sense of space and depth. Up in the middle and higher mid-range, I can still hear the width really clearly, but there's a significant risk that too much width in these regions will start to overwhelm important center-panned elements such as vocals. As we reach the very highest frequencies, I stop caring so much. Yes, I can still hear the directional information, but it doesn't make the mix seem big and wide and impressive in the same way that mid-range width does. I personally think that avoiding the mono down mix being dull and muffled in comparison with the stereo mix is much more important than preserving that very high stereo width. Okay, I'm going to leave you there. I've still not covered every potential application, like for example using the envelope follower to create dynamic width settings. But I need to actually get this video finished and uploaded at some point, so I'm going to call it there. Thanks for watching.